Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome back to my daily hour agenda that is PTT or Weekend Tech Talk. Okay, today I have one speaker that is Karisma Rishad Santosa from TFTP. For Karisma Rishad, you can start.
Bismillah, Assalamualaikum warahmatullahi wabarakatuh. Before we get into the weekend tech talk in this today, I'm going to introduce myself first. My name is Harisma Rishatantosa, and I'm from 10TKG. Now, in this opportunity of weekend tech talk, today we are talking about TFTP, that is Trivial File Transfer Protocol. Let me just present the share screen first. Oh, okay, in here we have said in here there is trivial file transfer protocol. So TFTP or trivial file transfer protocol is a simple lockstep file transfer protocol which allows a client to get a file from or put a file onto a remote host. One of its primary uses is the early stages of nodes booting from a local area network. The FTP has been used for this application because it's simple to implement. And the FTP was first standardized in 1981, and the current specification for the protocol can be found in RFC 1350. So the FTP is like transferring like a file about maybe you have in this host you have a file, and in this host we can use this TFTP like in here. TFTP can be easily implemented by a code with a small memory footprint. It is therefore the protocol of choice for initial stages of any networking booting strategy like BOOTP, BOOTP Bootstrap, and then pre-boot execution environment, and then BSDP, that is Boot Service Recovery Protocol, and other stuff. When targeting from highly resource computers to very low resource computers like SPC and SOC, like system on chip. And this is also used for transfer firmware image and configuration file to network applications like router, firewall, and then IP of the maybe like a phone, and other stuff. Yeah, but today TFTP is virtually unused for internet transfer. But we're going to so TFTP is like it's a protocol for transferring file implemented on top of the UDP/IP protocol using well-known port number 69. TFTP was designed to be like small and easy implemented, and therefore it lacks most of advanced features offered by more like robust file transfer protocols. And TFTP only reads like and writes files from or to like a remote server. So it cannot like list. It cannot list. So it will be like so much list about all the files. We cannot delete the files. We cannot rename any files, or directories, and it has not provision user authentication. Now, today too, for TFTP is used only at local area network. So only in the local. So if we at home, we're going to use the TFTP because we cannot use like maybe that is wide area network. That is like a very more advanced area network, so it can be only used by local. area networks. And in TFTP2, transfer is initiated by this client issuing a request to read or write a particular file on the server. The request can optionally include a set of negotiated transfer parameters proposed by the client under the terms specified by RFC 2347. If the server grants the request, the file is sent blank blocks of about, I think, 512 bytes in default, or the number specific by in the block size, maybe in the negotiation option by the RFC 2348. Each block of the transfer data, which is usually carried with a single IP packet, is in order to avoid IP fragmentation, must be acknowledged by an acknowledged packet before the next block can be sent. A data packet of less than 512 bytes or the agreed block size option signals termination of a transfer. If a packet gets lost in the network, the intended recipient will time out and might retransmit their last packet, which may be like maybe data or an acknowledgement, thus causing of the sender of the lost packet to retransmit that lost packet. So yeah, that's about like the details about NTFTP. And in TFTP there is three model of transfer. It is NetaSG and then octet and then mail. We're going to read all of them about this. And NetaSG is a modified from SG, which is American Standard Code for Information Interchange, defined in RFC 0x 7f, the printable characters of in space, and the 8 of the control characters. The allowed control characters including the null, the line feed, and the carriage return. The neta also requires that the end of the line of the marker on the host be translated to be the character pair CRLF for transmission, and that any CR must be followed by either LF or the null. Now we talk about octet. So octet allows for the transfer of arbitrary raw 8-bit bytes with the received file resulting byte per byte identical to the one sent. More correctly, if a host receives an octet file then returns it, the return file must be identical to the original. Number three, there is mail. Transfer mode uses the neta transfer, but the file is sent to an email recipient by specifying that recipient email address as the file name. RFC 1350 declared this mode of the transfer obsolete. The FTP uses UDP as the transport protocol. Of course, like maybe TCP UDP and oscillator model. So TFTP using UDP as its the transport protocol. So transfer request is always initiated targeting port 69, but the data transfer ports are chosen independently by the sender and the receiver during the transfer initialization. The ports are chosen at random according to the parameters of the network instance, typically from the range of optimal ports. Now, in here there is some like we can see some uh, image about how TFTP works. In here, there's number one, which is this one, is the initiating host A sends an RET, a read request, or WRT, which is write request, packet to the host of S, to the host that is called S, at the port of number of 69, containing the file name, transfer mode, and optionally any negotiated option under the terms of RFC 2347. Now let's see the second one. The second one replies when on option ACK if option were used. An ACK which is an acknowledgement package to hierarchy, hierarchy, and directly with the data packet to hierarchy. Packet is sent from a randomly allocated ephemeral port, and all future packet to host S should be directed to this mode. So the number three, we say number three in here. The source host send numbered data packets to the destination host. All, but the last containing of the size block of data, the 512 bytes default, the destination host replies with the number AC key packets for all data packets. Now let's see number four. The final data packet must contain less than a full-size block of data to signal that is the the last. If the size of the transferred file is an exact multiple of the site block size, the source sends a final data packet containing 0 bytes of data. Number 5. Receiver responds to each data with associated number ACK. Send response to the first received ACK of a block with the data of the next block. Number 6. If an AC key is not eventually received, a retransmit timer resends the data package. So yeah, TFTP is much more going to networking, about networking. TFTP has been always associated to network routing. One of the first attempts in this regard was the BTP, the bootstrap loading using FTP standard RFC 906, published in 1984, which established the 1981 publisher Trivial File Transfer Protocol standard RFC 783 to be used as the standard file transfer protocol for bootstrap loading. It was followed shortly after the bootstrap protocol standard RFC 951, which is the boot bootp, and then it was published in 1985, which allowed a disk class client machine to discover its own IP address to the address of the FTP server. And the name of the network is the name of NBP, that is a network bootstrap profile, to be TFTP transferred, loaded into memory, and executed. DHCP or Dynamic Host Configuration Protocol standard RFC 2131 was published in 1997, improving BootP, which is Bootstrap Protocol capabilities. And finally, the Pre-Boot Execution Environment or PXE version 2.0 was released in December 1998, and the update of 2.1 was made in public in September 1999, counting on FTP as its file transfer protocol. Intel has recently decided to widely support PXE within the new UEFI specification, extending the FTP support to all EFI or the UEFI environments. So the original protocol has maybe a limit that is like about 512. That is the 512 times like this, 65,535. That is about 32 MB, 32 megabytes. In 1998, this limit extends by about 4 gigabyte by TFTP block size option RFC 2348. If the fine block size produces an IP packet size that exceeds the minimum MTU in any minimalist IP stack implementation, and a host BOTP or PXE ROM does not implement IP fragmentation and resembling. And there's okay, maybe we just talk about that. And here are the documentation of every RFC in this world. This is the version one, that is the 783-906, which we can see in here. uh, b- but there's the published date, and then there's the author who actually use this who update this RFC. Okay, maybe we go to maybe configuration about talking about TFTP. Let me do share screen again. Okay, now we have seen. Now here. Now I have made like a topology. I have made a topology about talking about TFTP. We can do maybe going to this router first. I'm going to do uh, turn it on, and oh, maybe not in here. Copy flash, forgot the FTP. Oh yeah, the FTP. Surface. So maybe we do configuration in the router first. So, interface v0 0, okay, 0 0 IP add. We're going. Oh yeah, don't forget to we add the IP in everything. It's going to be 110, and the sub uh 20 25 25 0, and no shut. And now it's been config. So now, oh wait, I'm just going to okay here already done. So before we go into the configuration about the FTP, we can see in Cisco packet tracer. Now if you go put like in here, we go into entity device and you put out this thing server about the server. Of course it's like a server. And then now we can config. Now where do you find the FTP? You go to the surface and then see in TFTP here. Now here we have the all the files that we can do in this time. Now in here I'm going to try to mm, to take in the topology in this topology. Here, wait, sorry. Now in here we can see C1841. Now in here in this router is 1841. So that is the router 2950. That is 2960. Where's the 2960? This is about the the switch. Now everything that connected to the server, maybe like a switch or router, it will uh, maybe it will connect to in this TFTP. Now, as I said in the Wikipedia in here, that TFTP utilize UDP, so it has like so everything that connects to the server, it has a file that needs to be run to be in the server, and then finally it will uh, be it will be saved by the server to configure in this server, in this server. So maybe uh, we talk maybe this first. Wait. Sorry, why share screen first and wait a moment, forgot something about okay here. Now maybe let me share screen first. My share screen. Wait, where is it? Okay, hello everyone again. Now here we are going to copy running and config flash is 1.1.30. There you go. Now it's so file name is 1.30. Now this running config to yeah, we can confirm it there. Now so after we do this, it will goes to the server and then do save in here. Now it will save in here. We have to find out what the the file name, the thing that the destination file name. Now it will be put in the server. Now it okay. Okay, uh, maybe that's all for my talking about TFTP, TFTP in this session, in this weekend tech talk session. And yeah, maybe that's all for me. I'm going to give the host the the mic back. Okay, Faiz, you can close this session.
Okay, uh, for the good material from Charisma Richard Santosa. Maybe that's just all from me. Thank you very much for attention. Wassalamualaikum warahmatullahi wabarakatuh.